Today, we're going to be talking about chi-squared goodness of fit test. So let's say that we're given some data about some car crashes that were randomly picked out from all of the accidents that happened in the country and the days of the week that they occurred on. So I will write down the chart and then you can copy it down. So here are the number of accidents that we pulled from the Department of Motor Vehicles, and we want to know the question: are accidents as likely on each day of the week? Now we could do this a couple of different ways, or one way that we had from before. We could do 7 hypothesis tests or a bunch of hypothesis tests until we get one that doesn't work. The probability of Sunday equaling 1/7, and the alternate hypothesis is the probability of Sunday does not equal 1/7. And if that worked, we would have done the probability of Monday and the probability of Tuesday and the probability of Wednesday. And the last thing that you want to do, I'm sure, is to do 7 hypothesis tests, as much fun as you've had with them before. So that's where we come up with the chi-squared goodness of fit test. In the hypothesis test, we are going to first state what we're trying to measure, sort of like our population parameter. The parameter for this is the percentage or proportion of car accidents each day. So my initial hypothesis is that the probability for each day equals 1/7. My alternate hypothesis is that at least one day is a different percentage or proportion. And we won't know which day or if all of the days or 5 of the days, but we are trying to figure out whether it's one day or at least one day or none of the days, and then we can figure this out. Now in this we only really have 2 conditions. The first condition is that they are all independent. And we will say that each car accident doesn't affect another. Now the second one is the expected values all must be greater than 5. So when we do the expected values, since they're all the same, I'm going to take 699 times 1/7, which equals 99.9. And since that is greater than 5, I have met all of my conditions. Now the question becomes, what do we do for the chi-squared? Well, the chi-squared is going to be the summation of the observed minus the expected squared divided by the expected. So let's take a look. The first day we had was 20, and my expected was 99.9. So I'm going to do 20 minus 99.9 squared divided by 99.9, which turned out to be 63.9. Now, when I do this with 113 and 99.9, it turns out to be 11. For Tuesday, we had 126, 99.9, and it turned out to be 6.84. And we do this for the rest of them, which I will just list here as 35.03, 13.1, so I'll just round it to the nearest tenth, 1.73. And finally, for Saturday, I'll write it over here, 77.30. So when I add all these numbers up, the 63.86 plus the 11 plus the 6.84 plus the 35.03 plus the 13.08 plus 1.73 plus the 77.30, we get chi-squared actually equals 208.8. So, we also have a certain number of degrees of freedom. Now, since all of these categories are the same, and we've picked out some, we're basically going to have the degrees of freedom of the last one that would probably be set in place, so we're going to do n minus 1, in this case, degrees of freedom of 6. Now, the chi-squared distribution, generally speaking, when anything is bigger than a degree of freedom of 1, is going to be a distribution that is skewed to the right. And whenever doing a chi-squared distribution, we're going to do the probability that chi-squared is bigger than whatever number we got, which in this case was 208.8. So in our calculator we have a chi-squared CDF, which is, of course, we're doing a cumulative function, as we generally do. That should be enough zeros with 6 degrees of freedom. My calculator gave me 2.54 times 10 to the negative 42nd, which is most definitely less than 5%. At the very beginning, I should have put alpha equals 5%, and I would go back and put that back in there if I was doing this on a test. And so, our last point is to do the interpretation. We reject the null hypothesis we have reason to believe, I'm sorry, not reason, cross that out, evidence to suggest that not every day has equal chance of accidents. And I will continue this on part 2 with one where we're not just doing everything being equal, but a different percentage for each of the categories.